T7.6. A researcher initially plans to take an SRS of size 160 from a certain population and calculate the sample mean x bar. Later, the researcher decides to increase the sample size so that the standard deviation of the sampling distribution will be half as big as when using a sample size of 160. What sample size should the researcher use? All right, so this question is focused on the standard deviation of the sampling distribution of x bar, which, when we refer to our formula sheet, we see that here's how you calculate that standard deviation. Okay, so it's sigma divided by root n. Okay. Sigma represents the population standard deviation, n represents the sample size. Okay. All right, now we know what this value was initially. It was 160, but the standard deviation, we have no idea what that value is. Okay. It doesn't matter. We can just make up a value as long as we consistently use it throughout the whole problem. Okay. All right, so let's just assume sigma is 10. All right, that's the population standard deviation. Okay. All right, so then initially, right, we would have 10 divided by root 160. And 10 divided by root 160 is approximately 0.79. Okay. All right, now what we're going to do is just guess and check, right? We're going to try this sample size and see whether we get something about half as big. So we're looking for which of these answer choices gives us an answer of about 0.4. Okay, just make a note. Half would be approximately 0.4. Okay. All right, so let's test this out. So A is going to be 10 over root 40. B is going to be 10 over root 80. C is going to be 10 over root 320. D is going to be 10 divided by root 640. Okay. All right, so hopefully one of these gives us an answer in the neighborhood of 0.4. If not, then we could just say E is the answer by process of elimination. All right, so let's try the first one. 10 divided by root 40 is 1.58. All right, that's actually bigger, not smaller. And that kind of makes sense, right? We're dividing by a smaller number here. Okay, so A is not the correct answer. Let's try 10 divided by root 80. Okay, so that gives 1.11. Okay, which is not half as big. It's bigger than the initial standard deviation. Right, we'll do 10 divided by root 320. So that gives 0.56. Okay, so that's definitely smaller than what we started with, but not half as small. Okay. All right, let's try the next one, 10 divided by root 640. That gives 0.395. Right, which is pretty close to 0.40, which would be half as big as the initial standard deviation. All right, so the answer here is D. Okay. Now, if you're looking for an algebraic argument, notice that 640 is 4 times bigger than 160. Okay. So when we have, if we just do it symbolically, sigma over the square root of 4n, and you use algebra, this becomes sigma over root 4 times root n, which becomes sigma over 2 root n, which you can factor out the 2. This is going to be 1/2 times sigma over root n. Okay. So by quadrupling the sample size, you essentially end up with a factor of 1/2 when you use algebra to simplify.